Hey, good afternoon, everyone. Um, welcome to this presentation. We're just waiting a few more minutes, just to give a little bit more time for people to log in and join us. But I'm really glad to have you here. One thing to note, I posted a message on the chat. Please take a look at that. This is for the purpose to follow the GitHub project where this information stored. So we have the code, the projects there, documentation. So please follow that GitHub project for the code and all the code that you will see here today. In addition to that, please give it a star. Follow the GitHub project by getting a star. That can help us keep the work going because we do have a lot of stuff to uh, to continue to work on that project. And welcome, Armando. Armando, good to have you, man. Thank you. I'm okay, man. How about yourself? We should chat later. I think I still have your phone, so I'll give you a ring. Fermin, thank you for coming in as well. So we'll start soon. I think it's already 12:01, so let's let's uh, let's do this, okay? All right, so we are actually broadcasting also live on YouTube to record this, and we'll send the information later. But let's get going. Hi everyone. So please sound check, right? Everything sounds okay. Just say yes on the chat, please. But I think Armando heard me already. Um, thank you. All right, guys. So one of the from the user standpoint, right, one of the common things is that when they're working with dashboards and charts is for them to be able to understand the meaning of those charts, right, the meaning of the data that they are looking at, and if there is any type of action items that they need to take based on those charts, right. When the dashboards and charts are simple enough, there isn't any more that they can do or understand. But what if the charts are complex? What if the dashboards are very complex and the user is not familiar with the data, with the information, or even the processes that they're working on, right? So this user will need some training for that person to understand what is the meaning of those charts. So what we're hoping to do today is basically showing how we can leverage the power of AI to build, to enhance existing dashboards and charts, um, and leverage AI to add additional, to augment the data and do the data analysis for these users and give them some context and feedback and possible action items for them to be able to be more effective at their job. So welcome to Smart Charts, powered by AI. My name is Oscar Garcia. Really glad to have you here today. Um, what I do application architecture with cloud, web, data, and AI technologies. I've been doing this for a few years now. I enjoy learning and sharing what I learn with other people. That's why we do this. We are running this Google Developer Group and sharing information with you. I'm also an author of the book Data Engineering Process Fundamentals. You can find that on Amazon. And if you want to see more links about data engineering projects, AI engineering, machine learning. Also, there's a GitHub project there. That's a very good GitHub project that I created. You can scan that QR code that will take you to a portal where you can actually see the links, and you can follow those projects as well. We continue to do other presentations on those areas on a monthly basis. So thank you for being here, and let's get going. So before we start talking about using AI data analysis and charts. So let's understand a little bit why would that how why does that work, right? Why does that help us? So let's first understand the large language models, right? So this is really behind what's the engine or the architecture behind the generative AI models. That are designed to understand natural language prompts and questions to generate an output that's going to be like a human like text that we can understand, right? And the way they can leverage this is because they use large amounts of training data through machine language and through neural networks, and and they go through the entire data engineering process, and they train the models to do this, right? So one of the common tasks to be able to do this, to use these models, is for text generation, right? So we can use them to be able to perhaps generate code, do data analysis, and other questions and answers that we can send to them, right? But the key here is to be able to use a natural language process, right? So these models are very good at understanding natural language, and we'll see why. But it's kind of it's key to understand that we can't just send like a JSON payload and expect for the model to properly work, just like a human does, right? You can't just give a human a JSON without any context. You have to give them some context. And they're very good at text summarization if you need to summarize data, and like I mentioned before, questions and answers, right? One thing to notice here is that this AI models, just like any other technology, they keep improving, they keep becoming better, faster, support more tokens. So what you used maybe a month ago, that model may not be as effective anymore, and they have a new release. So just keep an eye on the model versions. Um, so how do they work, right? So how do they really work? How do they get to be good at learning or generating text, right? So because they use a combination of machine learning and deep learning, right? And if you want to see some of that, just follow that link to the GitHub project where I have a good introduction of machine learning as well. They use massive data sets of text uh, and code and information that picked up all over the internet, and they go and they feed it into this complex network with multiple layers, right? So they're able to process and understand the data. But right, so the key here is that, right? So there's the data collection. So that's a lot of heavy data engineering in there, and pre-processing. What that means really is just like any other data engineering task. You get the data, you clean it, you make sure there's no garbage in there, you process it, you do what's called the identify the features for what's called feature engineering. What that means is what are the areas that you're really looking to learn and target, right? And so for your model to be able to help you. And then once you get all this data, you put it through the network, and basically you do model training, right? So the neural network will actually just go ahead and train us data. So it will get the input layer, and it will go through the hidden layers, right, which are full of embedding, encoders, and decoding. And then we'll take a look at that as well. And then there is the process of fine tuning the models. Right? Fine tuning really is that you may have a model that's good at certain conversations, but it may not be good enough to have conversation based on your domain, right? So for example, your business, right? If you're asking questions that are specific to your business, the model doesn't know because it's not trained on that. So you can do fine tuning, which is enhance that model to learn from your data. All right. So behind the scenes of the architecture, right? The neural network architecture, there's something called transformers. And no, we're not talking about the Autobots, right? We're just talking about some of the components that they use in this node. So, for example, you have something called the encoder. The encoder really is what processes the input, right? So it gets the input and uses a mechanism called self-attention, right? And what that does really, it actually does analysis, right? Like if you think about when we're having a conversation, we basically may say a lot of things, but there's only 2 or 3 or 5 words that are key. and our brain tends to kind of put those keywords together and associate them. So that is the attention mechanism. And you can read it more about that. Just Google attention is all you need by Google, and which is right there on this. And then search on that and read about that book created by Google back in 2017. There's also the concept of decoder, right? So the decoder really, it just now takes the input, um, and it does its own work for attention mechanism to generate an output, like code, like data analysis, whatever it is that you're trying to do. So it's giving you the output. So just read about attention mechanism. That is really how this works under the hood for large language models specifically. So as before, I talked about fine tuning for a specific domain. So what that means is you could just pick up a model from somewhere, and then just enhance that by training it with your data, right? So you can just get your company's data, your information, and feed that into the process and enhance that model. And then now you have a specialized model that has all this foundational information. And in addition to that, your target data, your information that is specific to your business. And that's how you will enhance some of these large language models to support a business. Right. So one thing to notice here, though, as we work on large language models and generative AI, is that we need to build prompts, right? And there is a cost associated there, and there's a limit there as well. Like any cloud technology, right? The data in, data out, things like data bandwidth, what have you. There's a cost associated for that. So for these models, basically, they have the concept of a token. Right. So a token is really like a building block that they use to be able to package some of the data that you're sending together. Right. And the thing is that a token could be based on the model structure. Also could be a word, could be a symbol. It really depends on the architecture. The thing is, it will measure the amount of tokens you have. And it will just try, for example, if you use a prompt that is over the token limit for the request, then it will just say that's not supported because you exceeding the token limit. So what that means is your message is too big. Maybe your model only supports like 250 kilobytes, and your payload is twice that much. Then you will fail. So now at that point, you're gonna have to either upgrade to a better model, right, that supports more data, or you're gonna have to create some kind of session management where you actually can segment your prompt and send it in chunks so the model can have context of the full conversation, right? So keep be aware of that's how they measure costs. So you want to be efficient as you build your prompts, right? So but what are prompts, right? We're talking about prompts, and what is that, right? So that's really what they call it, prompt engineering, which is really the process of designing and organizing these questions, right? This text that you're building, that you're putting together to be able to ask the question of, can you help me, right? Can you help me with this chart? Can you do data analysis, right? But you just can't say, can you do data analysis? Can you generate this code, right? You have to give it some kind of context. You have to give it some kind of, you have to be specific. You have to be clear on what you're asking for. You have to, you kind of have to provide good context on what is the background of what you're trying to provide and what you're looking at, right? So for example, just like any humans, right? You can't just ask, hey, what is the meaning of this chart? But the first thing is, what is the chart type and what are you measuring? Right? And what are you expecting to see? Like what are you looking for? Sales, profits, defects, whatever it is that you're targeting. So you have to and to enhance it even better, you can provide examples of what you're not looking for, or for what you're looking for. It really depends on what you're trying to do. Right. So you have to be very clear and concise, and give it very good detailed instructions on how to what you're asking for, what you're looking for. So as an example that you see here, An example could be, hey, we are looking at a control chart measuring curvature with this manufacturing data, right? And we're saying this is the chart type, this is the chart title, this is some data points, this is the data series we're using, upper limits, lower limits. So if you notice some of this data, if you're not familiar with this kind of control charts, and you probably start asking, what's curvature? What is the meaning of that, right? So you can have an idea what curvature is, but what are we trying to measure? Why? What is this for? What are upper limits and lower limits, and what does that tell me, right? So if you don't know the specifics of that domain, then you will have to go through training and be able to understand what that's for. So with AI, we can probably minimize that and help the users. All right, so how do we do this chart analysis, right? And I promise this is the last one of the slides, and then we go take a look at the project. So we really can combine, if you have a dashboards and you have charts that you're using and you want to train users, then you can probably use AI to provide them with better interpretation of what the charts are, right? And also maybe some action items that they can take. Because on a chart like this, the data is actually, the purpose of this chart is not just to look at it, but actually to understand it and have an action item. So let's see what that means, right? So for the data analysis flow, you probably want to be able to get the chart data, right? So you want the key data points, you want the labels, you want the titles. You want to provide that level of information so AI is able to understand what you're looking at, right? And then you need to convert that not into, let's say you have a JSON, a payload for that, then you need to convert it into a natural language text, right? So you want to make it more meaningful to the model. So we can probably say, looking at a control chart measuring curvature data points, just like you explain it to a human, right? So by now you're adding context to it. You're adding data points and titles and chart type and things of that nature. And then the second component of this is, what are you looking for here, right? So you build this chart prompt, giving a context on what the chart is and the data, but now what is that you're looking for? What is the output that you want? What's the question? So the question is, please give us, interpret this chart. Tell me what this chart is for. What is the meaning of the data series? What are the limits, and is there any action item? So by knowing this, you could see that most of this data flow is within two. If you look at this chart, is within the upper red line and green line. And what this indicates is upper and lower limits. And what you see is that you see a data point that went outside the lower limits, which can represent a problem, right? So if you don't know enough about this, you may say, what does that mean, right? Does it represent a problem or not? So it really depends on what you're trying to do. Usually, if it's out of those boundaries, it does represent that the process is going out of control. It's out of control. So, all right, but okay. So let's now that we looked at this, so just quickly, I'll take you to where the code is. So what you want to do is you just want to go to GitHub, and it's on the link, and you can see this project here. And we have use cases with AI. You want to look at the Smart Charts project folder, sorry, and in there see basically all the smart charts. And this is a Python. Just to make it easy, we use Jupyter notebooks, right? Because it makes it easy for the presentations and for the integration. But then you will see, so you will have all the files here, and some of the basically the documentation on what this is, what are we looking at, and how to do it, how to install it, and so on. Okay, so when you get a chance, take a look. Please give it a start. That helps us big time. And what that means, really, you just go to start the project at the very top, right here. Thank you for doing that. And let's go back to so what I'm going to do now is just in Visual Studio Code, we're going to load the project, right? So this is really the project that I just pointed out to you through GitHub website. And basically, I'm just loading here the the project itself. So what you want to look into the Python, and look into Smart Charts folder, right? There you will see something called the files called chart analysis, and this is a Jupyter notebook. If you're not familiar with that, it's just a quick way to be able to run some code snippets, load libraries, and so on. So you can actually sort of do data analysis. This is great for data analysis with Python, do some quick prototyping, and then you can export this to just create your libraries, whether it's for Python, for data analysis, or any data pipelines that you're trying to build. But take a look at this, and the same thing can be done with OpenAI as well on Azure. I have some samples here for OpenAI as well, but not this specifically. But the code generation is there with OpenAI as well. But here to set up for Python, we need to be able to meet some prerequisites, requirements, what Python version to use, what Gemini API to use, and so on, right? So if you read all this information, you will see that we require Python 3.9. That's the minimum requirement for that. And if you want to install it, you can go through the sequence of commands, right, through the terminal, excuse me, and install Python. And also a key here is you need a key, right? Whether it's Gemini or Azure, you need to be able to get the key. So go there, get a key for your register, get a key for it, copy the key, and then you install it in your environment, right? And I give some commands here how to install it in your environment, so you don't have to paste it in the code, right? So it's not in the notebook, and it's not by mistake to push it to GitHub or anything like that, right? So, but for quick prototyping, if you want to, without committing anything to GitHub, you can just basically copy and paste it in the code, and you'll be fine. So you don't push it, or remember not to. And so here I advise to set up a virtual environment, so you can actually just within that environment install all the dependencies you need, and so on, right? So all that is just basically configuring your environment for development. But let's now talk about the dependencies, the libraries we need. We need Google Generative AI. We need Pandas and Plotly. And if you're not familiar with some of these, Pandas really is and NumPy are very powerful Python libraries for data engineering. Pretty fast. You can do a lot of great things with using data frames and doing the data frame transformation and so on. And Plotly is a great library for data visualization and data analysis, right? It enables you to build dashboards, charts, and so on, right? So you install all of that in your environment. You run that through the terminal. Once you do that, you can just run the code, right? So this is the code here. And what you're looking at here, I'm going to blow this up a little bit now that we're going to look at the code more in detail. What we're looking at here basically is what we're saying is that in addition to importing the Gemini library, we want to be able to define what model to use. And this goes back to the tokens conversation we had before, right? So if you use older models, what they call the context window, which is like the amount of tokens that it supports, can be probably under 250 kilobytes, which probably is going to support a lot of things that you want to do, especially for data analysis, because data analysis will require more tokens. And here you have models like the Pro and Flash, and basically what they do, they use this kind of versioning labels here to indicate the window, right? What they support, how many tokens they support. So 001 usually means 1 megabyte, right? 02, they already are working on 002 that supports 2 megabytes of data. So as you can see, they are improving the context window for tokens, and that means you'll be able to pass more data, but of course, it will cost you more as well. So be mindful of that. So here we get the key. We set the model name, and we do some utilities here for print markdowns, just a utility to display the output nicely. So we're not looking at just some text. So you run these cells, control enter to run this cell, right? That's how these notebooks work. And then here we can actually just run this pretty quick. And what we're doing here is we're saying, okay, if the key is set, just quickly let's build this model and let's ask this model a quick question, right? So the question here is that we're saying, hey, we're learning about models, large language models, and statistical analysis charts. What information do you need to help us explain this, right? So we're just asking for AI to help us. And AI is just going to say, hey, to effectively explain this, I need this, right? I need the type of chart, what data, the axis, the legend, the key features, and so on, right? So it's giving you good. You can ask those type of questions, right? When you're doing your work and your analysis, you can start saying, hey, how do I do certain things? And it will give you an idea, right? So this gives you an idea. You start thinking about it. Okay, so this is a way for me to, this is the type of stuff, information that is hoping to see. So let me see how I transform my information, my data, right? So I probably have a JSON payload. I don't know. We'll see. But transform it into this context. That's really the key here. And it's telling you right there. You see, the example is I'm trying to understand a bar chart that shows accuracy score and so on, right? And this could be a more complex chart, because what does accuracy score means for different large language models, right? If you don't know the context of that, well, it probably, this analysis can help you, and it will give you information on what's more accurate than the other, right? All right, so let's create our charts. Just to give you some background here, so we're simulating a manufacturing for augmented reality devices, right? So, for example, Magic Leap One that was released back in 2018. Right, it goes through this manufacturing process where we actually, let's say, we're building the lens itself. So all this device has a lot of components, right? So here, let's say that we just want to focus on the lens, the actual glasses that you see here. So we're going to generate some data, demo data, not real data, and we're going to be able to go ahead and do some analysis of that. So the way we do this is, so we import this from libraries that we have here, right? So we have some not libraries, but some Python files that we have here that we export some options, right? So we have what's called the IPs file and data prompts, right? And let's take a look at what they do, right? So for example, the first thing that we're gonna generate some IPs data. So if we browse that, if we go to definition now and we take a look at the code, so you can see the file name IPs .py, then we can see some of the data points that we want to look at, right? So we're going to look at angle, clarity, distortion, and so on, right? And these are data points that we're trying to analyze, right? So we can follow this, and this code it will generate that data set for us, and send that payload to us, right? So we can actually, once we run it, right, and we present the data, well, the data is going to be like this. So we're going to generate just as random generated data points, and we can see all this information that's here. Okay, so another thing to notice, though, is that in this file we also have something called create control chart, bell curve, and so on, right? So those are additional charts that we're going to be using, and all that information is actually stored in the same file here, and we can see how we can create a control chart using Plotly, right? So Plotly is our library. It will get a data frame, and we're going to just generate a chart here. And notice and keep track of every chart that we create. We want to be able to understand the data that was used for it, right? So for example, what is the chart type? What is the title? What is the data set that we're using for this? And if in this case, upper and lower limits, and we want to get that data and return it. So we're using a dictionary here, which is just really a JSON, right? It's a JSON object. We're returning that information. So so in the same applies for the bell curve, right? So if you can take a look at the bell curve, it's the same thing, right? And we go through it, we build it out with Plotly, and then we get the data, right? So this is different though, right? Because the data points are different for this context, right? We're just basically creating some more additional data points like the standard deviation, right? So you will see all this, the normal distribution, standard deviation, right? The minimum and maximum, and so on. So you see all these data points that are required that chart, right? And then those are needed for context, right? For the AI to be able to understand, okay, I see your standard deviation is this and all of that. So because it's a large language, not a scientific model, it's just really a model to understand a natural language, and then reply to us just like an expert will do, right? Oh, I see that this plot is doing this, and that, right? And your standard deviation tells you this, and that. And that is the goal here. So this is how we do. So this is the pattern, right? This is the pattern for creating these charts and be able to analyze the data, right? So here, one thing to keep track as well is how do we build the prompts, right? So you go to the data prompts file, and then you'll see exactly how we do that, right? So this converts a JSON into a natural language string with bullet points. So, and we'll see the output. Right now, it's kind of hard to see through the code, but the whole idea here is to map a JSON payload into a more human readable format, right? Which is really what the model wants. And you can probably use AI too. You could probably just feed that JSON AI, transform this into a human readable format, and AI will probably do it, right? So, but here we're just showing how you will do the transformation. Because remember, if you ask everything to the AI, that you will use more tokens, it will cost you more money, and so on, right? And then, so we have a build chart prompt and an analysis prompt, and there is where we actually can add more context, right? We have a context, and we will like some this, and this is the description, the chart data, and the questions that we're looking for. So this will just put all that information together to be in the context together to give the AI additional information. All right, so we read this data set, and we can see all the data points that we have here, right? So, and we're gonna focus on a few target columns, which what's called feature engineering, right, for analysis. So we're gonna take a look at that. We run this, and basically, we are saying that we want to focus on focal length, curvature, angle, clarity, distortion, and so on, right? So these are the data points we want to look at, right? So what we do is we're just gonna at random, we're gonna select one data point, and we're just gonna run that, right? And we're just gonna load a control chart, and this is what we just generated from this data set, right? It says, okay, you may be looking at it, but because I know this, I know everything looks to be under control, like within the control limits. So everything looks as a control process. That's the definition of this, right? So, but let's look what it really means, right? So for example, if we go here and we say, hey, what does this data looks like, right? So we're just gonna quickly just do this, right? And we're gonna say, we're just gonna basically do this, right? We're gonna print this information. This is what the dashboard, when you generate the chart, that function that we looked at, right? The build the control chart. This is the data that is sent back, right? The chart type, the title, and so on. The data points, the lower limits, the upper limits, and so on, right? So this is the JSON that we get back. But this is not what we want to do. We want to grab that JSON, and we want to actually build that chart prompt that we saw, right? So we saw this. That's going to get that payload, and it's going to do a human readable format. So as you can see, we transform that JSON in this bullet list of data, right? So control chart, we're looking at the angle, right? Well, these are the data points that we picked. Control limits are this, right? So we have that information now. We have that context of the data now. So let's take a look at how we can do analysis, right? And this is now the human training someone and saying to you, a control chart is like this, right? So think about it from that perspective. So we're looking at a control chart to measuring this particular feature with this data, right? We're plotting this numeric series with value and control limits. Analyze there, and please answer the questions. Tell us about the purpose of the chart, and if there's in items, basically that we need to take on, right? So this is where you actually need to be specific about what you're looking for, and this is the analysis piece of it. So what we do now is just build this out, and we create this prompt, right, which is the entire information now. So now we're saying this is a chart type, this is the data, this is the limit, and now the information, right? So we're actually saying what we want the AI to tell us, right? So at that point, now that we have a decent prompt built, we can actually ask the AI, and we can send now that prompt to them. So this is generate model, generate content. We're really sending what we just saw on top to the model. The model is going to say, hey, the purpose is of this control chart is to monitor the angle measurement in this manufacturing setting, right? And it tells you what is doing, right? What problems could be there, right? It tells you, it understands, hey, I see that you have control limits, which is a key for this analysis, right? And then you can see by examining the data points, we can see that all fall within the control limits. This indicates that the process is in statistical control, right? There are no points that exceeds the limit. So that means the process is within control boundaries, right? Which is really what we're asking the explanation, because this just alone doesn't explain too much. But if you read the context now, right? And this is what the user sees, right? The user won't see that JSON, the user see that prompt. This is what the user wants to see. So the user wants to see this explanation, right? So it tells you also your action items, continues to monitor, right? Investigate potential causes of variation, right? That's when maybe the data goes out of limits and so on, right? And it just explains to you what is happening. And that is how you can actually make this smart speak to your users, and the users can have a little bit more context, right? And the same applies. We could create using similar features, we can actually create other additional plots for this. Let me go ahead and I'm missing something here. I think the labels data frame. So I missed something here. Chart data. All right, so DF labels. All this looks okay. Let's see why this one is not working. Okay, so let's investigate that later. Why is this box create box plot? Oh, because it's not imported. I forgot to import this chart, so we'll ignore this one. I forgot to import that chart into the library, so let's not do that one. So let's just go ahead and take a look at this one. So here we're gonna be able to do a little bit more. I think the error is something different, but we'll take a look at that later because we're running out of time. But this is another one, right? So this is the analysis of what it will say from a previous example, and it will explain to you what it's doing. Same for if you want to do a histogram, right? You can run a histogram, right? And you can use the same data, the same feature, and you can ask, right? Hey, we're analyzing this histogram, right? Can you tell us what this histogram is for, right? And we can give all that context, all that information, build a prompt, right? And then generate the content, right? So we could just go ahead and do the prompt here again. Let's not do the analysis yet. Let's just do that. And it just tells you really, if you want to print this pretty, right? It tells you what the prompt will be, right? And then you can actually use that to do the data analysis here, right? So we can just go ahead and tell the model, hey, this is my prompt. Let me go ahead and analyze the histogram for me, please. And it will just tell you, right? This is the distribution. It tells you it's centered around 45. And you can see that is centered around here, which is not, this is not a good bell curve. There's a lot of, it's not really within all the parameters. So it's a little, the data is not that good, basically. But this explains that to you, right? Saying, hey, there's no major gaps or outliers and potential issues and so on. So this all that information gives you all that analysis, right? And it helps your users understand what's going on. Okay. There's also an example of how to use an image, but because this is a language model, sending image data doesn't really help. But it's there for if you get like a vision model to be able to analyze the actual image itself of the chart, then you can use that. But anyway, so just go ahead and look at the code, continue to play with it, understand it, and please uh, let us know how we're doing. All right, so okay, so what we learned today is that we can use the large language models for analysis, right? We can actually go and use something that exists, make sure that we grab that JSON, we send the data, we create a prompt with the chart context, like chart type, the title, the series, any kind of specifics like lower limits, upper limits, and so on. And we have to provide guiding questions, right? What is the overall trend? Are there significant peaks or outliers? What are the takeaways? What action items? Is my process out of control? What should I do? And so on, right? So by framing the prompt with good context and guiding question, we can train the model to analyze the chart in a more human-like understanding and present back to us some information. Okay, so hey, for a lot today. If you have any questions, we do have a couple of more minutes. Anything that I see a question by Marco? Yes. You will get an email with all the slides, the video, the recording on YouTube. This is being recorded, by the way, and all the information you need. So you just take a look at that email. Please give feedback about the presentation. Start the GitHub repo, please. That helps us a lot. So also, if you want to learn more about data engineering, do take a look at this book that I publish. You can scan the QR code for the link. It's on the it's on Amazon, so you can buy it from there if you want to. But that is basically we concluded this presentation. If you have any questions, anybody? So the book is more of the data engineering process fundamental. This book has a focus really more on building data pipelines, doing data transformation and so on, which is a key fundamental of machine learning and AI, right? Because you need that data process. That's what the book focus is. So it's about data warehousing, data lakes, data pipelines, right? If you want to take a look at prompt engineering and learn about that, just do take a look at that GitHub repo. So I do have documentation on that, on what that means on prompt engineering. I have also code examples on how to generate code from building out prompts to generate code using AI. So take a look at that repo. So the repo, one thing that a lot of people don't realize, but the GitHub repos are not just for code, right? It's not just to push your code there. It's really to document everything. So you will see README files and things like that. That gives you all the documentation to be able to do that. So, and if you're interested in machine learning, that repo is pretty good. I get good ratings on that one, good reviews. Just scan the QR code, look for the machine learning repo. That go really step by step on learning how to build out what is machine learning. What is the purpose of that? And you will see a lot of similarities with data engineering. It's a lot of data engineering activities around there. And I hope that so I gather so much information about machine learning that I'll probably publish a book on that as well. So yes, Igor. So I do have so all of these recordings will be on GitHub. I'm sorry, YouTube. So we have a what do you call it? We have a series, right? Escaping my mind right now. Uh, But so if you look at GitHub, there's a lot of presentations that will touch on data lake, building data lakes and data warehouses, specifically on that. Using data visualization tools like Power BI, Looker, using Python for data visualization with the tools, with the libraries that I show you today. No, I have not talked about data cubes, OLAP. I could definitely talk about OLAPs as well. I have done that in the past, but honestly, in my experience, OLAP is a technology that's still being used. And it was used heavily 10, 12 years ago. But with the power of data lakes and data warehouses on the cloud, the process of data cubes has, or the usage of data cubes has been reducing, because you can have, for example, Microsoft Synapse, you have Google BigQuery, you have Snowflakes, you have all these data warehouses engines that use blob storage, and they're pretty fast. They're pretty incredible. And back then, storage was not that fast, and that's why Data Cubes OLAP was created to compile that data into cubes, so you can actually do multi queries and so on. But that's actually now being handled better by cloud technologies. But anyways, yeah. Please just send us feedback. Keep following the Google group. We'll probably start doing some of this in person as we get more people interested in doing that. But keep just join that YouTube channel. Please follow there, and you'll see a lot of information about AI, data engineering, and so on. Okay, guys. Thank you for your time. I really appreciate it. It has been a pleasure to be here sharing this with you, and I look forward to speaking with you next time. Okay. Thank you, everyone. Have a good day.